Hello friends and welcome to our video. In this video, me and my group mates will be talking about the Varactor Diode. We will cover the topics of its symbol, constructions, working, characteristics, and its applications. So this is the image of Varactor Diode. Varactor Diode is a type of diode whose internal capacitance varies with respect to the reverse voltage. Varactor means variable reactance. Varactor diodes are also known as varigap due to its variable capacitance, and due to this, varactor diodes has many applications in devices requiring variable capacitance. This is the symbol of varactor diode. The symbol of the varactor diode is similar to that of the PN junction diode. The diode has two terminals, namely anode and cathode. The one end of the symbol consists diode and other has two parallel lines that represent the conductive plates of the capacitor. The gap between the plates shows their dielectric. Before understanding the construction and working of the varactor diode, it is important to understand how a normal capacitor works. The formula for the capacitance is given by C is equal to the epsilon A divided by D, where C is the capacitance in farads, epsilon is the permittivity of dielectrics. For understanding the construction and the working of varactor diode, it is important to understand how a normal capacitor works. The formula for the capacitance is given by C is equal to epsilon A divided by D, where C is the capacitance in farads, epsilon is the permittivity of dielectric. A is the area of the parallel plates and D is the distance between the plates. So from this, we can note that for a fixed permittivity of dielectric, the capacitance can be varied by changing the distance between the plates of the capacitor, as it is inversely proportional. That is, if we increase the distance between the plates, the capacitance decreases. Varactor diodes also work in a similar pattern.
Now we will see the construction of the Varactor diode. The Varactor diode is made up of the p-type and n-type semiconductor. In the n-type semiconductor, free electrons are the majority carrier and holes are the minority carrier. So the free electrons carry most of the electric current in n-type semiconductor. In the p-type semiconductor, holes are the majority carriers and free electrons are the minority carriers. So the holes carry most of the electric current in p-type semiconductor. When a p-type semiconductor is in contact with the n-type semiconductor, a p-n junction is formed between them. This p-n junction separates the p-type and n-type semiconductor. At the p-n junction, a depletion region is created. A depletion region is a region where mobile charge carriers are absent. The depletion region is made up of positive and negative ions. The positive and negative ions does not move from one place to another place. The depletion region blocks free electrons from N side and holes from P side. Thus, depletion region blocks electric current across the PN junction. Now, we will explain the working of the Varactor diode. Due to the existence of PN junction, the depletion region will not allow the current to pass through and instead charge will be stored in the depletion region. And when we apply a reverse bias voltage, the width of the depletion region will change. That means we increase the applied reverse bias voltage, then the width of the depletion region will also increase. And as the depletion region width increases, then from the equation of the capacitance, we can say that the value of the capacitance will reduce. That means this capacitance is inversely proportional to the applied reverse voltage. We can use the general formula of capacitance for a Varactor diode. C equals to epsilon A divided by D, where C is the capacitance of the diode, epsilon is the permittivity of the semiconductor material, A is the area of PN junction, and D is the width of the depletion region. Further, we can write C equals to CO divided by 1 plus V over Vf whole raised to n, where V is the applied bias reverse voltage, Vf is the built-in voltage of the diode, CO is the capacitance of the diode in unbiased state, and n depends on the doping profile of the diode.
Now I will explain the characteristics of a Varactor diode. Firstly, capacitance. The capacitance of a Varactor diode changes as the applied reverse voltage changes. This change in capacitance makes it useful in many electronic applications such as in voltage controlled oscillators, frequency synthesizers and phase-locked loops. Non-linear behavior. The relationship between the capacitance and reverse voltage of a Varactor diode is non-linear. This non-linearity makes it useful for generating harmonic frequencies and for mixing signals. High Q factor. Varactor diodes typically have a high Q factor, which means that they have a high level of energy storage and a low level of energy loss. This high Q factor makes them useful in high energy applications where low losses are essential. Low noises. Varactor diodes are typically low noise devices, which means they generate little to no noise when they are used in circuits. Temperature sensitivity. The capacitance of a Varactor diode is highly sensitive to changes in temperature. This sensitivity can be both an advantage and a disadvantage depending on the application. For example, it can be advantageous in temperature compensated oscillators, but it can be disadvantaged in circuits where temperature stability is critical. In reverse bias mode, the Varactor diode enhances the capacitance as shown in the graph below. From this graph, we can see that as reverse bias voltage increases, the capacitance decreases, and when the reverse bias voltage decreases, the capacitance increases exponentially. On to the applications of Varactor diodes. Firstly, voltage-controlled oscillators. Varactor diodes are widely used in voltage-controlled oscillators (VCOs) that are used in radio and communication systems. The variable capacitance of the Varactor diode is used to tune the frequency of the oscillator. 2. Frequency modulators. The Varactor diodes are used in frequency modulators to modulate the frequency of a carrier signal. The voltage applied to the Varactor diode modulates its capacitance, which in turn modulates the frequency of the carrier signal. 3. Tunable filters. Varactor diodes are used in tunable filters that are used in communication systems, radar systems, and other applications where frequency tuning is required. The capacitance of the Varactor diode is used to adjust the center frequency of the filter. 4. Phase shifters. Varactor diodes are used in phase shifters that are used in phase array antennas. The capacitance of the Varactor diode is used to adjust the phase of the signal. 5. Voltage-controlled attenuators. Varactor diodes are used in voltage-controlled attenuators that are used in radio and communication systems. The variable capacitance of the Varactor diode is used to adjust the attenuation of the signal. Now lastly, I will explain the use of Varactor diodes in tuning circuits. As shown in the figure, here Varactor diode is employed in the tuning circuit. So for the given tuning circuit, the resonant frequency f is given by 1 divided by 2 pi square root of LC dash, where C dash is CT plus CC. So here CT is the capacitance of the Varactor diode, while CC is the coupling capacitor. So as you can see, as we change the applied reverse bias voltage, we can change the value of this capacitor. So in this way, we can tune this circuit to the particular frequency. So these Varactor diodes are used in FM receivers as well as in other communication equipments where the circuits need to be tuned electronically. With this, we come to the end of our video and our presentation. If you have any doubts regarding our topic, then you can ask them in the comments and we'll be sure to reply. Thank you for watching.